Yeah, I know, but this is a tutorial now. So, what problems do we need to see? You want to start with 18 and go backwards then? Okay. Yep. Oh yeah, we can. Yeah. What page do you want to start at then? 17. Yeah. Well, let's just start with 18 then. So, what did you want to see on page 18 up there? Another one for number 3. Yeah. Which one will I do on number 3? Okay, let's do both. No problem. This is on page 18 now. Now I'm going to, I know this one is a bit hard, so I'm going to try and take my time so you can all keep up with this, okay? Guys, are we listening? Listen. No? Question? No? Okay, I need you to listen because this one's a little bit hard. So let me just write it down first. Yeah. Okay. Great, okay. Equals, I don't need to write equals. Alright. What number? Sorry. Dude, it's on the screen. Okay. I'll just wait for everybody to settle so we can have our full attention on this. So this question says it has basically one root. Technically, it's more accurate because, you could have 2 roots, but if they're both the same, then do you say that's 1 or 2 roots? So to prevent any confusion, you should say one distinct root, one unique root. Yeah, just to prevent language confusion. So, yeah. Yeah, it's the safest thing to do. I mean, you don't have to use the word distinct. You could say one unique root, one distinct. No, I need a synonym for unique or distinct. Something like this. Like, I don't think there's any more than that. Okay. So one root means the discriminant equals 0. That's what one root is. Which means b squared minus 4ac equals 0. And just to be clear, in green here this is a. Blue here this is b. And red here this is c. So you have now b squared, so that's 2k minus 2 squared, good. And then 4, good, and then minus k minus 1. And that should equal 0. Yeah, okay. Now, this is a square. So just to make it even more clear, because it's a square, you can actually write it like this. 2k minus 2, 2k minus 2. Because that's what square means. So minus 4, minus k plus 4, minus k minus 1. That should equal 0. Now, you tell me, which do you prefer to do? So you have a choice here. You can multiply these two together first, and then multiply your answer by 4. Or, what you can do is, you can take the 4 and multiply it by this bracket, and then after you do that, multiply your answer by the next bracket. So in other words, what do you want to do with the 4? Do you want to multiply it in first or last? Because you actually can do it both ways. It doesn't matter. What would you prefer to do? First or last with the 4? Put the 4 in first. Yeah, so put the 4 in the first one then. So we'll do that. So we have 2k minus 2, 2k minus 2, minus bracket. And now, do you want to put the 4 in, or do you want to put the minus 4 in? Do you want to take care of the minus now or later? No, we'll take care of it now. Okay, so So we have plus, and then we can take the minus 4 and put that in. So we'll get 4k minus 16. And it only multiplies the first bracket, equals 0. Okay. Right, now, it's not so bad, is it? Because we have these two brackets to multiply and these two brackets to multiply. So let's multiply. So, you know, first by first, first by second, second by first and second by second, first by first, first by second, second by first and second by second. So that would be 4k squared minus 4k, isn't it? Minus 4k again. And finally, plus 4. Plus, minus 4k squared minus 4k plus 16k plus 16 at the back equals 0. Now this is really nice because this guy, they cancel. Yeah, so that one cancels with that one. Minus 4k minus 4k minus 4k is minus 12k. Plus 16k is 4k. Plus 4 plus 16 is plus 20, isn't it? Equals 0. So then you get 4k equals minus 20, divide by the 4, and we get our final answer, k has to be minus 5 then, okay? So write that one down if you need to write that down, and then we'll have a look at, in a minute we'll have a look at Z. You at the back, Sabrina, you asked me for this one, and you at the front, you wanted this one as well. So how is it now? It's okay? Yeah, we'll do, it's very good, okay. We'll still do 3Z now in a moment. What the heck? Oh, I must have knocked the button here. There we go. Oh, you don't need to take pictures of this because it's gone on YouTube, so. I'm in no rush. You can write it down. I've got my coffee. I can wait. There's no problem. The purpose of a tutorial is to give you time to get your head around all this stuff, so I don't want you to feel like you're rushed. Did you give these a try? Yeah, and how did they go? Like, for example, this one here, where did it all go wrong?
It didn't go wrong, I didn't ask you.
Okay, well, in Z then?
Yeah, no, I just want to make sure I did it.
Oh, okay, alright, right. You think they're okay, though?
The first time I did, I think it was wrong, and then
okay.
You know how sometimes you get the answer just by luck?
You want to make sure, right, okay. What are we looking at after 3Z then? So I'll do 3Z now. Would there be more from this page, or from this page?
3N.
Okay. What's so special about 3N? What about it?
Central.
3N. Haha, yeah, okay. Oh, that's a good one. Yeah, no, I will do that one. Were you asking for Z?
Yeah.
Okay, we'll do 3N instead then. Right, yeah. You know this word, don't you? Yeah, okay. So what was I meaning when I said that? Minus k minus 1 x squared plus 6k plus 6 x plus minus 9k plus 5 equals 0, but I don't have to write that down because what I'm saying is this has one real root. Okay? So, it has one real root. Let's see what happens. Discriminant equals 0. B squared minus 4ac equals 0. 6k plus 6 squared minus 4 minus k minus 1 minus 9k plus 5 equals 0. Yeah? So that's 6k plus 6, 6k plus 6 plus 4k plus 4 minus 9k plus 5 equals 0. Okay, multiplying time. So in total this will be 36k squared plus 6k plus 6k plus 36 minus 36k squared plus 20k minus 36k plus 20 equals 0. Go and go. 12k plus 20k is 32k. 32k minus 36k is minus 4k. 36 plus 20 is 56, right? I feel like something's got a little bit off here. Am I adding these up right? 6 and 6 is 12. 12 plus 20, okay? 12 plus 20 is 32, right? 32 minus 36 is minus 4. And then what about my numbers? 36 and 20 is 56, right? Okay, 56 equals 0. No, I feel like I've done something wrong. Did I write the question down wrong? That would be the first thing to check. Minus k minus 1, 6k plus 6, minus 9k plus 5, 6k plus 6, 6k plus 6, minus 4. Do you spot a mistake? What's the mistake?
6 times 6, 36.
Did I not write 36?
No.
Oh, I wrote 6. Should have been 36, thank you. So that's my mistake there. 36 and 36. So that's 72. 72 plus 20, 92 minus 36. What's that? 92 minus 36. So 56k plus 56 equals 0. Great. So what's the k? K equals minus 1 then. Which is a problem. The answer's not this. Why?
Because that would have no
No, that's not that. Why is this wrong? Or rather, why is this a problem? Why am I saying there's a problem with my answer? I mean, it seems fine. Nobody can spot it? No? Can anyone see the problem with my answer? No? No. You're clutching at straws, man. Anyone? No? Hang on, yeah? What should be 0? No, k doesn't need to be 0. I mean, it seems okay. I didn't make a mistake this time. But there's something bad with my answer. Okay, I'll tell you then. You know?
Maybe it's less than 0.
No, that's not a problem. It can be less than 0. It can't be minus 1. And the reason it can't be minus 1 is because it would make this part 0. And it wouldn't be a quadratic anymore.
Yeah.
So think about what happens if you use minus 1. Your quadratic would become this. 0x squared plus 0x, and then you'd have plus 14 equals 0. So you have 14 equals 0 then. So if you use minus 1, you make a quadratic that isn't a quadratic and doesn't have a solution. So we should be remembering that k cannot equal minus 1, because then it's not quadratic anymore. So it was a bit of a trick question. There actually isn't a value of k that can make this quadratic have one real root. It's impossible to make this quadratic have only one real root.
So that's the answer.
It's not possible to make it have one real root. Yeah. Yeah. Yes.
So sorry, but in the example, we're given this kind of question, so we state not possible because of the
Yeah, I suppose if you wanted, like if there's an exam, the final answer would be, so you would have to write here, but k cannot equal -1, so therefore no answer exists. And there you go. Yeah. I don't think they would do anything like that in an exam. I don't think so. It's a little bit too unfair. Okay. What else? Now. No. And anyways, I write the mid-semester, but it's only a. No, I won't do that in the mid-semester. Well, I don't think I will. Anyway, the mid-semester doesn't count towards your final grade anyway, so. We'll see how I feel nearer to the exam. Okay, what else do we need to see now? Yep.
On page 16, can you do 4 and 5?
Yeah, I can do 4 and 5. Now, 4 and 5 were optional questions. You didn't have to do it.
Yeah,
But some people tried it, so they might want to see it. So let's have a look at 4 and 5 on page 16. Okay. So you have 4x4 minus 5x squared minus 9, and I want you to solve that. And my hint is u equals x squared. So that means u squared equals x4. Yeah? And it didn't work? Oh, good. So you have 4u squared minus 5u minus 9 equals 0. But as you said, you could have spotted that this is a quadratic like this. 4x squared squared minus 5x squared minus 9. But you didn't have to do that, because I actually suggested using u. So this is the quadratic to solve. Okay? So you get u equals minus b plus minus square root b squared minus 4ac. So that'd be 16 times 9. That's 160, 150, 144 all over 8. So u equals 5 plus or minus 169. Square root of 169 is 13, isn't it? 5 plus or minus 13 over 8. So you get, it's either going to be 18 over 8, which is 9 over 4, or minus 1. You can't have it yet, because you can have u equals 9 over 4, or u equals minus 1. But u, we said, is x squared. So you can have x squared equals 9 over 4, or x squared equals minus 1. But this makes no sense, because you can't have a square equal to minus 1. So finally, you say x equals plus or minus root 9 over 4, which is plus or minus 3 over 2. So it's kind of similar in number 5 as well. Have a look if you like. Oh, did I make it have 4? Okay. We'll do 5 in a minute. Okay. Can we look at 5? Yeah. So in 5, what have we got? We've got 36x4 minus 145x squared plus 44 equals 0. And this is like a quadratic, but instead of x, it's x squared instead of x. You know, you can see that in the middle. The middle guy should be an x if it's a quadratic, but it's an x squared. So it is still a quadratic, except instead of using x, we're using x squared. So we have x squared equals minus b plus or minus square root whatever no, don't tell me. No, don't tell me.
Sorry.
Shh. I'm thinking here.
I was just gonna say 145.
Yeah, okay, alright. 4 times 3 is 12. And that's a 3 and a 1 is a 4, and a 0 and a 1, 4. 1822. Is it 18225? Ah, no, it doesn't.
Yeah.
Something went. Oh no, sorry. I know what I did wrong. Let me try again. No, let me try. What is it? It's this 21025. Okay, that's better. Right. So 21025 minus 144 times 144. Alright, no, I've reached my limit there. What's 144 squared? What is it? Maybe someone can just give me the entire square root part at this point. Is that for the whole root? Thank you. All over 72. Yeah. Wait. 16 squared is 255. Is this 17? Yeah. So 145 plus or minus 17 over 72. Okay. So x squared is, we'll do the plus 1 first. So 145, 155, 162? 162 over 72? Yeah? Is that right? Or 137 over 72. Is that the 2? Is that the 2? It's not 137? Oh, sorry, 127. 127 over 72? Oh man. Of course, 128. And was the other one 162? Yeah? Okay. Can they be simplified?
Yeah.
Of course they can, yeah. So what do you get? 9 over 4 or... Ah, great. So then when you square root, yeah, you get 3 over 2, minus 3 over 2, 4 over 3, and minus 4 over 3. The 4 answers. Yeah. Yes? Oh, how we did in number 4? Yeah, it's fine, yeah. That's fine, yeah. Right, what's next now? What's next? Next? There must be more questions.
Why is it that we use plus or minus twice?
When you take a square root, you have a plus or minus, and there's 2 things to take the square root if you plus minus twice. Yep. Back to 18, yep. 2n. Okay. Yeah, alright.
Wait.
What? Oh, you need to write this down?
Yes, just 100.
Yeah? It's okay? Alright.
I'm checking the answer was correct because I felt like I did something wrong, but yeah, this is correct.
Is that good? Right, page 18 to N. So my question here was, how many roots does this have? Minus k x squared plus 3k minus 4x plus minus 2k plus 5. How many roots does this have? Well, let's see. Discriminant is b squared minus 4ac. Yeah? So if you were to multiply that out, what would we get? We'd end up getting 9k squared minus 24k plus 16 minus 8k squared minus plus 20k. So we'll end up getting k squared. Is this right? Something seems like it went off a bit. No, I guess so. K squared plus 20k plus 16. Now, is that positive, negative, or 0? Well, we know it's... Well, I suppose it could be 0 depending on the k. It could be positive, it could be negative. I think it'll probably be a positive number on the right. Let's see. So this is equal to k plus 4 squared. Oh, it's actually equal to exactly k plus 4 squared. This is quite interesting. So, what can we say about the discriminant? Is it positive? Yeah. Why is it positive? Because it's a square. Could it be negative? No. Could it be 0? Could be 0, as long as k could be minus 4. Could k be minus 4? Yeah, it could be. Just couldn't be 0. So, the discriminant here is greater than or equal to 0. So, the answer is it could have one or more roots. Now, I don't actually know if I wrote it like that at the back. Let's have a check. Yeah. 2n. So I really perhaps should have said one or more. I mean, it could have 2, but it also could have 1, depending on the case. So, another way to say that, one or more, you could write that as 2 roots, but they both could be the same. Or you could write it also as no roots. I think it's the nicest way to write it. No roots, yeah.
How did you get 20k?
How did I get 20k?
Minus 4k.
Oh, right.
Yeah, I was looking at that too.
Thank you. Back in time we go. Dun, 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 dun. Minus 4k plus 16. Does that change it much? Maybe. K, yeah? Minus 2 squared, right? Plus 12.
Yeah.
Ah, okay. So we don't get to say no roots. We simply get to say 2 roots. Okay. Right, thanks for that. So I had a mistake here. It's minus 4k. I wrote plus 4k.
0 plus 20k.
Oh, whatever. It was certainly wrong. Now it's right.
So it can only be x.
In the exam, you know, you might get something like this, but they won't make it quite as difficult. So what they might do is they might put a k here, they might put something like 3k minus 4 here, but they might just put a single number at the end. They might just say like plus 1. Okay. I prefer to make my questions a tiny bit harder than the exam, because it's worse if I did it the other way. If I made my questions a tiny bit easier than the exam, it makes the exam seem more difficult. Yeah. So in other words, if you can do this, then you can certainly do the exam question, which will be a little bit easier than this. So that's, I try to make my questions a tiny bit more difficult, because you never know what will happen in the exam. Okay, so what do we have next then?
Page
12, yeah.
question number 5.
Yeah, I was waiting for someone to ask me for this one. So which one do you want me to do?
No, it's just a doubt because I did earlier I did in the example question I did a method and you said that it sounds like you just got it by luck, but
Oh yeah, okay.
yeah.
You saying you got the same again by luck?
I got all the answers using that method.
Okay, well, let's have a look at that method then. So let's try and look at it in detail. So which one did you try there we can look at? A. Yeah, okay. No, like, maybe I was too quick to dismiss what you were doing because perhaps I wasn't fully aware of what exactly you were doing. So, describe to us your method. So what did you do first here? Oh, this is 5A on page 12. So what did you do first?
If you can do B.
Yeah.
Yeah.
Oh, you want me to do B?
Yeah. B.
Okay. Y equals minus 9x squared plus bx plus c.
Yeah.
Okay, so what did you do first?
So I just I made C equals minus 569.
So you made C equal minus 569, which is fine, okay?
Yeah. And I did, because it says it has a vertex at x.
Yep.
I just took completing the square method for the x squared and x, and I just took 9 out and put
You factored out the 9.
minus 9 equals times x plus 8 the whole square, and I just multiplied 9 times 16.
I see what you're doing now. So what you did was, it's like you drew a line here and you don't care about the number at the back. You multiplied out the answer, so that would be blah blah blah, and then the middle one would be whatever 16 times 9 is. What was it? 144x.
Yeah.
And then you have your thing at the back which you don't care about, and you said, well, this is supposed to be the same as this, so it means 144 is supposed to equal b then. Oh yeah, okay, I like it. So you started, so the way you're thinking about it is you're looking at the answer and going back to the question.
Yeah.
Whereas I was looking at the question and trying to match it up with, yeah, okay. No, same idea, just a different direction. So that works perfectly fine then. Yeah, no, that's fine.
I was wondering.
So no, it wasn't that you were getting it right by accident. Yeah, no, it does.
I was wondering if it works only for these.
No, this is a good idea. So you take your answer, yeah. But you can't know this in your answer.
Yeah, you don't need to know it.
But you don't need to know it, yeah. No, that's good. Okay, what else do we need to see?
We're going to solve it?
We have the answer, 144.
Can you solve it your own way?
My way. Now, I don't think my way is necessarily better. But I will do it my way, yes. Okay. So I have y equals minus 9x. What one were we doing? B, wasn't it?
Yeah, B.
Plus bx plus c. Now, we know that it crosses the y-axis as minus 569. So that means when x is 0, y should be minus 569. Okay? So we can change this into this. Is that okay so far? Yeah? Now, I want to complete the square here, so I take out the minus 9, and I have x squared plus, well, it will be x squared minus b over 9x plus whatever 569 over 9 is. So y equals minus 9 bracket x minus b over 18, isn't it? Yeah, b over 18 squared plus, and we have something here which we don't actually really care about, because we can see from this that the vertex will be at x equals b over 18. Yeah? But I tell you that that happens when x is, you know that happens when x is 8. So basically by combining these two you can say that means b over 18 should equal 8. Which means b is 144, 18 times 8. Yeah. So, I mean, it's the way our methods differ is you wrote down what the answer should be and went backwards, whereas I was pretending I know this, and then when I get to a point I can't continue, I realise that this is something I actually know. It depends on how you think about it, you know? Yeah, because that's how you normally find the vertex, you know? To find the vertex, what you do is you picture this piece here as 0. Yeah, and we know that the vertex happens at 8, so it means whatever this makes it to be 0, it should also be 8, so it means this has to be the same as that. So you get that.
Wait, you said to find the vertex, you picture what is
Yeah, you picture the square part 0.
Equals 0.
Yeah.
Okay.
Yeah. So the only way that could be 0 is if x is b over 18. But you know what x should be. X should be 8. So therefore b over 18 should be 8. Yeah. Now I've seen this one in the exam once or twice. So it has been in the exam. However, there is another way to do this which is actually a little bit easier, but we can't do it just yet because we haven't studied it. But for those of you who know calculus, you could actually use calculus here to get the answer in less steps. It's a little bit easier.
So you just substitute y equals minus 569. That should be right?
Yeah, because that's where it crosses the y. Actually, I'll just pass this around for you. Okay. Anything else now?
Can you do 6?
On the same page?
Yeah.
Yeah, which one?
And
Anyone? Give me a letter. Your favourite letter between A and L.
G.
G, okay, why not? Alright. So 8x squared plus 144x plus 653. Right, now, give me your favourite number. What's your lucky number?
1.
1. Wonderful. So if I put in 1 here, we can see that it's a positive, right? In fact, what I think is, well, it's not clear, but what will happen is, no matter what value of x, this will be positive, okay? If you choose any x, my claim is that 8x squared plus 144x plus 653 is positive. That's my claim. Now, I actually say that in the question. I say that these things should be positive or negative. And if you don't believe that it is always positive, you think, no, I think I could make this negative. Well, try to make it negative. Try to put in a value of x to make this negative, and you can't. There's no number that you can put in that will make this negative. But how can I prove that? Well, I can prove that by completing the square. So if I change it into 8 bracket x squared plus 144 over 8x plus 653 over 8. There's 144 over 8 is 72 over 4. Is it that 18? Yeah, it's 18, isn't it? X squared plus 18x plus, is this anything? No, it's not. Still 653 over 8, isn't it? Yeah. Right, completing the square, that's 8x plus 9 squared, and then 653 over 8 minus 81. What's that? 653 over 8 minus 81, please. 5 over 8. So that's 8x plus 9 squared plus 5. Now it's quite clear to see that this has to be bigger than 0. Because this is always positive. It could actually be 0, so it's always bigger than or equal to 0. And this guy is obviously always bigger than 0 because it's 5. So when you have two things which are added together, one of them always bigger than or equal to 0, and the other one always bigger than 0, the result is always bigger than 0. So that is the end of the proof. If you have two numbers, one which is 0 or greater, and the other one is greater than 0, and you add them together, the result is something which is always greater than 0. Yeah? Hey, are you here for the next class?
Yeah.
Ah, well, you can sit down. We're about finished here. Yeah. Again, I've seen this one in the exam maybe 3 or 4 times. It's actually been a while since it came up. Once you mark your name off the attendance list, you can then leave. Okay, just make sure you mark your attendance. I can close this. Is that signed? Is that finished? Just, if everybody signs it, just bring it up, please.